So today we're going to look at what happens when pieces of the Earth's crust or plates collide. So our essential question, what you should be able to answer after reviewing and taking these notes, what land or crust features form when tectonic plates converge or when they collide? This is called a convergent boundary. When tectonic plates, those are pieces of the Earth's crust, collide. So to converge means to come together. And there's three types of convergent boundaries. When oceanic crust collides with continental crust, when oceanic crust collides with other oceanic crust, or when continental crust collides with other continental crusts. And we'll look at all of these types of convergent boundaries. And we need to know what landforms, what features happen at all three of them. When oceanic crust converges or collides with continental crust, you get subduction. And we saw this last week a little bit when we looked at our seafloor spreading diagram. Now, instead of focusing on the seafloor spreading part, we're looking at what happens at the edge of the ocean basin where it collides with the continent. So you can see the lithosphere, or the outer part of Earth's crust, our tectonic plate, is pushing towards the continent, and the continental crust is moving or converging with the oceanic crust. The first thing you need to know is that, remember, the ocean crust is more dense than continental crust, and dense things sink or go down. That oceanic crust will go underneath or get subducted underneath the continental crust, and this is called a subduction zone. That dense ocean crust gets pulled under the continent. It's hot under there, it melts, it gets recycled and becomes part of a rock cycle again. Anytime you have a subduction zone, you get two features or two landforms. One, where it starts to dive underneath, you get a deep, deep trench. The second thing is anytime you have melted rock, anytime you have subduction, some of that rock that melts pushes back up. And when you have melted rock or magma, or when it's above the surface, we call it lava. When you have that lava come above the surface, it makes volcanoes. So anytime there's subduction, you get a deep trench and you get volcanoes. We can look at a real world example on the coast of South America. So first, if we're looking at this world map of different tectonic plates, we're going to focus in on this blue area here, the circle, the blue circle. We can see in the middle of the Pacific Ocean, you have that seafloor spreading. We're going to look at this turquoise Nazca plate as it's colliding or converging with the plate that South America is on, that pink South American plate. So we're looking at this convergent boundary, and that's what we're zooming in on here. So right on that west coast of South America, the ocean that the Pacific plate is on, called the Nazca plate, is getting subducted. It's going underneath that South American plate. So you have this subduction zone here. Again, anytime you have subduction, you get two features. You get a trench. So a trench is just a really deep underwater, like kind of carving out in the crust. And then again, anytime you have subduction, some of that melted rock or lava comes back up through the surface and makes volcanoes. So all up and down the west coast of South America, we have the Andes Mountains. Those are volcanic. And the Andes Mountains are famous for being right on that coast, for being really tall. Some of them are active volcanoes. And that's because that Pacific Ocean plate is being subducted underneath the South American plate. And that subducted material melts and comes back up and forms this volcano chain all along the coast here. You can also have two continental plates converge. Continental crust is much thicker than oceanic crust. So when two continental crusts collide, neither one of them will get subducted. They kind of fold or push up against one another, and they can make mountains. The best example of this is the Himalaya Mountains in India. So looking at our world map of tectonic plates, we're going to look at this area in the blue circle here. We're looking at the Eurasian plate, which has Europe and Asia, which is green. And then this little tiny yellow one here is the Indian plate or the Arabian plate. And that Indian plate is colliding with the Eurasian plate. And if we zoom in on this area here, you can see India is pushing up and colliding with that Eurasian plate. When those two plates collide, they push up, they converge to make mountains, and they make the Himalayas. The Himalayas, in fact, are still growing today. They get taller and taller by a few centimeters every year because these plates are still converging and pushing up against one another. The last type of convergent boundary happens when two ocean plates converge. So at an ocean-ocean convergent boundary, one piece of the ocean crust will get pulled under the other. And again, anytime something goes under something else, that's called subduction. And again, just like we looked at the first example, anytime you have a subduction zone, you get two things. You get, again, a deep trench. You also get volcanoes. So if we're looking at two different ocean plates colliding, where they converge, you get one plate subducting or going under the other. You get a deep trench. And again, anytime you have subduction, some of that melted plate will come back up to the surface. That melted plate comes back up and it makes volcanoes. We saw earlier volcanoes on the coast of South America. Now, if we're in the middle of the ocean, if we have two ocean crusts or two ocean plates colliding, we still get volcanoes, but there's no continent. It's just an arc or a curved line of volcanic islands. Our best examples of ocean-ocean convergent boundaries are looking at the Pacific Ocean. So first, you may have heard of the Mariana Trench, which is very famous. It's extremely deep. If we were to look at the depth of the Mariana Trench, it's actually deeper than Mount Everest is tall. The Mariana Trench is over kind of near Australia and the South Pacific. And the Mariana Trench is where two ocean plates are colliding. So we have this yellow Pacific plate if we're looking at the world map up here, and the yellow Pacific plate is converging or colliding with that brownish Australian plate. And where those converge, you get subduction. One plate goes under the other, so it makes a very deep, deep, deep trench. But you also get some of that melted plate coming back up to the surface and making volcanic islands. And so all along this Pacific plate, so all along this yellow plate, we find volcanic islands. And the volcanic islands of Alaska, they're called the Aleutian Alaskan Islands. That just means Alaska. They're in an arc or a curve because that plate boundary is curved, and they're all volcanoes that happen because one plate subducted under the other plate. The other resource that you should be looking at this week is the Convergent Boundary Cheat Sheet. You're welcome to print it off or bookmark it. You don't need to copy it if it won't help you at all. But reminder, we need to remember there's two types of crust, continent and ocean. Continent crust is really thick. Ocean crust is pretty thin, but ocean crust is denser, it's more compact. So if we're looking at convergent boundaries, those three different ways that two plates can collide together, you can have, like we looked at first, continent and ocean converge together. So that dense ocean crust will get subducted underneath that thicker continent crust. You get a trench and you get volcanic islands like the Andes Mountains in South America. When two ocean plates will converge or collide together, one will go under the other. Again, anytime you have subduction, you get a trench, that deep area, and then you also get that volcanic island. So the Mariana Trench, the islands, the volcanic islands of Alaska. Or when continents collide together, because they're so much thicker than oceanic crust, continental crust doesn't get subducted. It just pushes up and folds up and makes mountains like the Himalayas in India. Please make sure you reach out to your teacher if you need help with anything. Next week, we'll look at other types of boundaries, but this week we're really just focusing on colliding or converging plates.